All right, so here we are already in week 4. We're moving quickly. We're gonna focus this week's video on we're gonna keep our focus on experimentation, right? Specifically this week, I want to look at a little review of correlation, which you did at the end of last week, and then this week you're gonna move into setting up an experiment, and you'll, towards the end of the week, go over the basics of statistics, which you need to know. And in next week's video, I'm going to have more on statistics, kind of as a summary of what you should make sure you have. But my comic, I hope you like. We got our control group this week and our out of control group. No, just kidding. All right, so like I said, we're going to review correlations and then do a little quiz. You won't have a partner, but you're going to make up some data to show a correlation. To show, I can't spell, a correlation. All right, we're going to look at the features of a true experiment. So what do you have to have a true experiment? And then we'll make sure you understand the assignments for this week. So remember that we have this kind of overview of scientific methods. And we looked at a naturalistic observation. Last week you looked at the survey questions. I hope you really get that it really matters how we word the questions, right? Sometimes we find something that we want to find because of how we ask questions, so be very careful. And I hope you saw how interesting case studies can be in psychology, but how they don't really, they're really limited to talking about that one person or small group of people, and the results don't necessarily generalize to others. But these allow us, these observations and surveys and case studies, they allow us to maybe form a hypothesis, right? To create how do we want to define things? Today we're going to talk a little bit about social media usage and things like depression, anxiety. Well, we have to be very clear how we measure those things, right? So there's lots of different measures, scales that have been created to measure those things, but by just saying depression, we don't agree on what that means. Like you could have something in my head and I could have something, or your head, and I could have a little bit different definition in my head. So we have to make sure we're very careful to operationally define these things to say exactly how we're going to measure. And we're going to look a little bit more, again, at a correlation is establishing a relationship, right? Does one variable predict the other? And we're going to look at today, if I want to establish causation with an experiment, what must be present? So we very careful, and I think this is all over everywhere, you've seen it, is that correlation need not mean causation, right? And here's a very funny one. Length of a marriage positively correlates with hair loss in men. So that means that we have, length of marriage, so a longer marriage correlates with a man losing hair, right? So that if a man is bald, he's more likely to have a positive marriage. Length of his marriage is likely to be longer. All right, does that mean that marriages cause men to lose hair? That's the joke, right? I think for Homer Simpson, it was more babies meant hair loss, right? Caused hair loss. But we have to be very careful that just because two things, one predicts the other, doesn't mean it causes the other. And so here's a review of some key terms here, right? And I think this is really important because you see a lot of questions, right? So correlation and prediction. If a variable exists between two variables, what is this X? It's usually used in ex post facto design. What does that mean? Ex post facto. It means after the fact. All right. So I'm measuring something that has already happened, right? Length of marriage, I can measure after, right? Or kind of ongoing, but I can still see, I'm not manipulating anything here. I'm just measuring how long have two people been married, and it's in the past. And this also is, there's no manipulation. If I'm looking at how long somebody's been married, I'm not saying that you get to be married less or longer. I'm not creating any kind of condition there. I'm just measuring what was. All right. And when we do this, we end up with, never like this, by the way, it's never perfect, right? But a perfect positive correlation means that as one variable goes up, right? Let's say this is length of marriage, and this is amount of hair loss, right? More hair loss. A perfect correlation will be R equals 1, right? No relationship at all, R will equal 0. And a perfect negative correlation, which means as one variable goes up, the other variable goes down, right? So let's think of something as one variable goes up, the amount of time you spend exercising, your weight may go down, right? If we looked at correlation, that might be something we would find. Really, we hardly ever see these perfect correlations. If I look at a positive correlation is something like intelligence score and academic achievement. Those two things are positively correlated, right? The higher your IQ, the higher necessarily your academic achievement or SAT score, but it's a 0.7, right? So remember, the plus is not telling you good or bad. It's just saying as one variable goes up, the other goes up. The negative is saying as one variable goes higher, the other variable goes lower. So that's the positive and negative part. And then the number, which is between 0 and 1, is telling you how good of a prediction it is. So the closer it is to 1 or negative 1, the better predictor it is. So let's see. Pause this video, right, and see if you can answer these questions. So it says, which of the following news reports are examples of positive correlation, and which is an example of a negative correlation? All right, so pause it and then answer. This is one of the things you'll show me that you've written down, and then I'll go through and quickly give you the answers. All right, the first one says the more a college student sleep, the better their academic performance. So as one goes up, more sleep, better performance, positive, right? So we would put a, do I have a plus here anywhere? Geometry, basic, plus. There we go. Positive. All right, the more time girls spend absorbed in online social media, the more at risk they are for depression. So this again, positive, right? One goes up, the other goes up. The longer children were breastfed, the greater their later academic achievement. Positive, right? One goes up, the other goes up. The more leafy vegetables you eat, the less their mental decline over the ensuing 5 years. So that one's going to be one goes up, the less I think is the other goes down. All right, so that one's going to be a negative correlation. So I don't have a subtraction sign. All right, how would we interpret the correlation coefficient of negative 0.87? So think about, what would I need to say? Right, 1, it's strong, right? This is a good strong correlation. It's negative, right? So that means as one variable is going up, the other variable is going down. So this is a strong negative correlation. All right, so just check and make sure you got that down. So we have, do ice cream sales predict murder rates versus do ice cream sales cause murders to increase? So these would be two different things I might be thinking about. And if we just looked at the graph, I got number of ice creams sold, right, and murder rate. It's going up. Not perfect correlation, but definitely a strong positive correlation. Does this mean that ice cream sales cause murder rates? Can you think of something? Can you pause and think of something else that might be happening that makes this relationship exist? This is an example of what's called an illusory correlation, and it's because people are closer to each other. There may be because it's hot and they're more likely to be kind of at odds with one another, but mostly they're just closer to each other. They're not in their houses, right? So we can clearly see that if we can, like, more people eat ice creams when it's hot out, and more people are outside around each other when it's hot out. So there's this variable that's behind here that we're not measuring, right? And this happens a lot in correlations, right? So this is kind of illusory correlations are why we cannot say, we can say ice cream sales are predictive or murder rates predict ice cream sales. Either way we could go with that, but we can't say that they cause each other. All right, let's look at one other reason why we would see a correlation that doesn't exist. And we have this concept, we're going to talk about this more next week when you've learned more about statistics. It's a little bit hard here, but we can give the basics of it here. Regression to the mean means if an outcome is extreme on its first measurement, it will be closer to the mean on its second measurement. So when we take something and measure it on we ask somebody one time, right? It might not be so extreme on the second. So this was the joke here. My grades are not falling, they're regressing to the mean, right? So this student would have to be getting amazing grades in everything, and then the next term, the next time it's measured, their grades are a little bit lower, right? And the parent's like, huh? Right? So, right, that doesn't say it has to happen. It's regression to the mean is not a must, but we see it in lots of different ways. The more children you have, right, even if both parents are very, very intelligent, for every child there's a decrease in intelligence. There's a regression to the mean. So the next child is closer to the mean than the child above. Now, is it meaningful? Probably not. It's like a difference of like 1.5 IQ points, but it does happen. And so sometimes if I measure something one time and there was some extreme values in that, the next time I measure it, I might not get the same thing. All right, so let's practice one more time with you making what we want to investigate overall with our experiment, our fake experimental design this week, is we can see that around 2010 we have this big increase in use of smartphones and social media. And then at the same time, simultaneously, we have data from Canada, America, British teen girl rates of depression, anxiety, self-harm, and suicide also go up. These are the studies that show this. I want you to just take a minute, just make up a scatter plot, right? So make up a scatter plot that has two variables of interest, right? On one is going to be phone use, right? So if I, and you could do phone use or social media use, but you have to define what you want it to be. Right, so down here, you're going to say some variable and be kind of specific, right? So hours or minutes spent on TikTok per day or whatever you want it to be. And then variable 2, you can write rating of self-esteem or self-like, or rating of, or how often, it can be very simple, how often do you think of harming yourself, right? Could be whatever you want, doesn't matter, and we're making it up. You don't have to go find the data. I just want you to stop it and stop the video and make up a pretend scatter plot. All right, so when you're ready, you'll restart the video. I'm going to keep going, but I hope you paused it and you made your scatter plot. What I hope you made, and what I just am making sure you see, is that each one of these little dots that I add to, each one of these little points I add to my scatter plot is a single subject, right, that I've measured. So this person spent relatively low minutes on social media, on TikTok, and they don't think of harming themselves very much, right? And that how you put these on here, right? This person spent a little bit more time, they have a lot of harm, or much more, and I haven't numerically put values to them, but that each one is representing a person that you have measured, right? How much time, and again, this is post facto, right? Because they spent this time, and maybe you looked on their phone, or maybe you just asked them, but all of this was done in the past, and their rating of themselves. And so I create a scatter plot, and that scatter plot is going to tell me, does minutes on TikTok predict how much they're likely to harm themselves? All right, so just see if you were able to create that. Now, where we want to move to is taking this correlation, whatever you're interested in, and again, you can do this after you use the resources this week. You can make up your own experiment. Just don't do it. We're not allowed to do experiments. We're not going to an ethics board. We're just making up what we want to do. And we need to know, well, what do I need to put in my experimental design? I want to establish a cause and effect relationship. I want to say, right, if in my case, I want to say minutes on TikTok causes an increase in self-harm. That's what I want to be able to say. Not predicts, but causes. And I want to establish this cause and effect relationship. So what do I need to have? All right. Well, first, I need to know who is going to be in my group, right? And this is where we come to this term, random selection. This term right here. I'm going to make it pink. All right. So I need to figure out who is going to be in my experiment. And so I have a population here. That's represented by this big black circle. And let's say I have to say who is my population at the very beginning. Who is going to be in my study? So I am going to have in my study teen girls from America. And it's probably, that's a huge population, right? Let's even learn it. Teen girls from Ohio, right? That's who my population is. And we could argue whether this would represent teen girls from Montana or Missouri or whatever, but I have to define who I want my population to be. Now, if I go to the mall, right, or I go to Starbucks, and I ask the first 50 girls who walk into Starbucks, right, I'm creating a really biased sample, right? There are some, so let's say there are some set of these girls who go to Starbucks, right? But how do I know that the girls who go to Starbucks are representative of all these girls? I don't, right? So if that would mean my population is girls who go to Starbucks, not teen girls from Ohio. So I have to be very, very careful of how I select from my population. And the best way, because you don't have to know this so well, is to know I want to use the term random selection, right? So I want every girl, right? Oops, doesn't matter the color. I want every girl that represents, so you imagine that this black circle was not a solid black circle, but it was a bunch of little dots. So all the girls that were in Ohio, all the teen girls, and I'm going to randomly select some. And now my results should count or generalize back to all of those girls in Ohio because I randomly selected it. So we're technically saying the girls in my study, they're not really different from any of the other girls from Ohio because they're random. So the randomness basically allows you to control for what you didn't know to control for. All right, so now I have my sample, right, my set. And I'm going to take this sample and I need to think about, well, what do I want to manipulate here, right? And it's pretty easy. If I want to know, does minutes spent on TikTok cause you to harm yourself? Well, my experimental group, my group that has something, right? So they're going to, and maybe I don't just have two groups, I could have multiple experimental groups. So let's say I'm going to limit, one group is going to have 4 hours a day, right? One group is going to have 8 hours a day. And then my control group, the group that doesn't have anything, is 0 hours a day. And we have to be careful here because maybe we're going to get a huge problem by taking away their social media, right? So maybe I have 0 hours a day cold turkey, right? So we just took away their phone right away versus 0 hours. This actually, we're gonna complicate it too much. We won't do that. So we're just gonna say 0 hours a day. But it can't be kids who have never had a phone either because that runs it in. So maybe I'm gonna not do 0 hours a day. Maybe we're gonna do it 2, right? So it wasn't completely nothing. Or we could have 2, 2, 4, 8 here, and 0 here. You can see that this becomes complicated, right? So 0 hours a day. So I have 2 groups. Now, this group, remember I took these from my population. I have this sample. And the next question is going to be, how do I decide who goes into which group? Well, that's where this term random assignment comes in. Because in random assignment, I'm going to take this group. It's going to get completely split in half, right? Or in this case, fourths, right? Because I have 4 different things going on here. So it's going to get completely split in fourths. But again, I have to be careful that everybody, remember it's a whole bunch of little dots in here, all my different subjects, they all have equal chance of going to each group. So that's where random comes in, because there could be different things about these girls that they have in common that I don't know about, so I'm going to control for it by randomly, right? So this girl, I flip they have a number dice, some random thing about which of these groups they grow to. So I need an experimental group and a control group. I need to randomly select from my population, and I need to randomly assign to my control groups. Now, the next, let's see, independent versus dependent variable. This is going to come up a lot. My independent variable, here we go, I need a text box. All right, so let's do dependent variable first, because this is always, it doesn't matter. Independent variable is always my grouping variable. All right, so in this case, it is this 2 hours, right? So this is the grouping variable, or the number of hours on social media, right? It's what I'm manipulating, right? So I'm manipulating it, and it's helping me make groups, and helps me make my groups. Right? That's my independent variable. My dependent variable is what I'm measuring. So, and what is being measured? So my independent variable is causing a change in my dependent variable, and this would be, we said number of times, I was doing number of times report self-harm. Right, that's what is being measured. So I'm trying to see, does the independent variable cause the change in the dependent variable? And the last part here is, I need to be really, really careful that I don't kind of influence anything by how I'm measuring something. Right, so in a single blind, the subjects don't know what group they're in. But this is very hard here because you would know how much time you had. So in this case, I can't really keep my subjects from knowing the group. But when we're taking medication or something, we use what's called a placebo, right? Or I might be really clever in my design. Maybe I didn't say 0 hours a day. Maybe I put only positive things on social media or something. I mean, I could make it be single blind, that they still have their phone, they're just not on TikTok. So maybe we could find a way to blind this out. But single blind, the researcher still knows. So I would know who's in each group. In a double blind procedure, the researcher, the one measuring, doesn't know. And this is really important because, as we saw last week with Clever Hands, when the guy knew what was being, what the number was, and the audience knew what the number was, the horse knew how many times to push on the ground, right? So we don't necessarily want our researchers to know who's in which group, because they may influence it in some way we don't know. All right, so as you work through your experimental design this week, you're going to need to make sure you include all these parts. And so what will that look like? All right, so you can work on this in groups. If you want to have a partner, you can both turn it in and work on it together. We are not conducting these studies, all right? We're just doing it to practice writing a experimental design. You need to say, who's your population? You need to say, how will you get that sample? It can be very simple, by the way. You need to state your research question and a hypothesis. So in my case, my research question is, does minutes spent on TikTok cause you to think about self-harming? My hypothesis would be my guess, right? What I think would happen is, yes, the more time you spend on TikTok, the more you think about harming yourselves, or it causes that to happen. Your operational definitions of each variable, right? Again, how are you going to define? And then how will you set up the experiment? How are you going to deal? We didn't necessarily talk about confounding variables directly, but confounding variables are those things that you don't know to measure, like maybe age matters. Maybe it matters how old you are. So maybe I want to measure that in my girls, right? Experimental and control groups, random assignment, single blind versus double blind, and any biases that you might want to control for. And then state what conclusions you could draw from your findings and to what extent your findings can be generalized, right? Who can your results be used for? All right, lastly, let's look real close at the course page. All right, to see what's up here for this week. Your video you're watching right now, you're going to work on designing that hypothetical experiment. You'll work on a statistics concept map because we didn't really talk at all. What do you do when you collect that data, right? When you have all this information, how do you know what it means, right? And you're going to look at that in the lessons, both this concept map, there's a little quiz, there's a little discussion on statistical significance, all right? And then there's a practice, this is extra and optional from your textbook if you want to look at the descriptive statistics. I might put one more up. All right, and then at the very end of the week, you're going to look at the ethics. How do we make sure we experiment ethically? All right, so that's what's for this week. And next week, I'm going to kind of revisit statistics to go back over this a little bit, and we'll wrap up our Unit 0 next week. All right, so please let me turn in what notes you took from this lesson and any questions you have, and I'll get back to help you.